In this video, we will talk about the importance of the init process, how system D and upstart arose and how they work. Use the system control to configure and control system D. Okay, let's get started. The init process. As being init, usually just called init, is the first user level process or task run on system and continues to run until the system is shut down. Traditionally, it has been considered the parent of all user processes, although technically that is not true, as some processes are started directly by the kernel. Init coordinates the later stages of the boot process, configures all aspects of the environment, and starts the processes needed for logging into the system. Init also works closely with the kernel in cleaning up after processes when they terminate, right? Traditionally, nearly all distributions based the init process on Unix is a vulnerable systev init software. However, this scheme was developed decades ago under rather different circumstances. The target was multi-user mainframe systems and not personal computers, laptops, and other devices. The target was a single processor system. Startup and shutdown time was not an important matter. It was far less important than getting things right. Startup was viewed as a serial process divided into a series of sequential stages, termed run levels. Each stage required a completion before the next could proceed. Thus, startup did not easily take advantage of the parallel processing that could be done on multiple processors or cores. Secondly, shutdown reboot was seen as a relatively rare event, and exactly how long it took was not considered important. Today, Linux systems usually boot in a matter of seconds. Three most common implementations include systemd, upstart, and systev init, but all major distributions have now moved to systemd. Modern systems have required newer methods with enhanced capabilities. Startup alternatives. To deal with the intrinsic limitations in systev init, new methods of controlling system startup were developed. Well, there are others. Two main schemes that were adopted by enterprise distributors, Upstart and systemd. For startup alternatives, there's Upstart and the systemd. Let's dig into the Upstart first. It's developed by Ubuntu and first included in 2006, adopted in Fedora 9 in 2008, and Red Hat Enterprise Linux 6 and its clones. Was also used in various embedded and mobile devices. Systemd is Fedora was the first major distribution to adopt it in 2011. Red Hat Enterprise Linux and SUSE followed. Ubuntu 16.04 replaced the Upstart with systemd. All important Linux distributions are now based on systemd. Migration to systemd was not a travel, and bugs and missing features could be very disabling. So essential compatibility layers were adopted and still exist for legacy softwares. Thus, systev init utility compatibility wrappers still persist. The history of the systemd development and adoption is rather complicated, and colorful personalities ensured not all the discussion was both friendly and technical. But this holy war is over as far as we are concerned here. So in the following, we will concentrate on systemd and for the most part ignore systev init as well as upstart, which is no longer used in any significant way. Systemd features. The systemd system and the session manager for Linux is now dominant in all major distributions. Features include the following, right, on the screen. Boots faster than previous init systems, provides aggressive parallelization capabilities, uses socket and dbus activation of starting services, replaces shell scripts with programs, offers on-demand starting of daemons, keeps track of the processes using C groups, maintains mount and auto mount points, implements an elaborate transactional dependency-based service control logic, can work as a drop-in replacement for systev init, and it's compatible with systev init scripts. Note that system D is backward compatible with the systev init, and the concept of run levels is supported via run level targets. The tail init program is emulated to work with run levels. Instead of a bash script, system D uses .service files. In addition, system D sorts all daemons into their own Linux C groups, control groups, right? System D configuration files. Although System D prefers to use a set of standardized configuration files, it can also use distribution-dependent legacy configuration files as a fallback. An example of a new configuration file would be etc hostname, which would replace etc sysconfig network in Red Hat, etc hostname in SUSE, and etc hostname adopted as the standard in Debian. Other files might include etc vconsole.config, the default keyboard mapping and console font, etc sysctl.d, *config drop-in directory for kernel sysctl parameters, etc os release distribution ID file, right? Exactly which configuration files will depend on how each distribution sets things up. For example, etc vconsole.config, which configures virtual terminal defaults, does not appear on Ubuntu systems. System D is backward compatible with the systev init, so using old commands will generally work. It supports the use of run levels conceptually through the mechanism of a run level target. In addition, tail init is emulated to work with run levels, right? Sysctl Systemctl is the main utility for managing services. Its basic syntax is a sysctl options command name, right? Below you can see some examples of how you can use the sysctl. They're showing on the screen to show the status of everything that a sysctl system D controls. You run systemctl, right? To show all available services, you do systemctl list the units -t service -all. To show only active services, you do systemctl list the units -t service. To start, activate, or stop, deactivate one or more units, you do a sysctl start, stop. There are 4 commands in the middle of the screen. Where a unit can be a service or socket, you do enable, disable service at the bottom of 2 commands on the screen, right? These commands do not actually start or stop a service. They control whether or not it is started up at a system boot. For most commands, you can, emit.service attachment attached to the service name. This is the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.